In this video, we are going to learn how to factor using the factor tree method and the ladder diagram. Let's begin. Use a factor tree to find the prime factorization of each number. What do we mean by that? Well, we break it down. What two numbers multiply to get you 18? Well, 9 and 2. And can we break 2 is a prime number, so we can't break it down any further. Can we break down 9? We can. What two numbers multiply to get you 9? 3 and 3. And can we break down 3 any further? We can't. So what I'm going to do is I'm going to circle the prime factors, and I'm going to write them in order from least to greatest. So 2 times 3 times 3. And if you know about exponents, 3 times 3, if I have two 3's, I can just simplify the way I write that. 2 times 3 to the second power, because I have two 3's, or 2 times 3 squared, if you want to call it that. Now, what if you did it a little bit differently? What if you decided, I don't know, 18 is 6 and 3, because 6 times 3 equals 18. Would you get the wrong answer? No, you'd still end up with the right answer, because you can break down 6 with 2 and 3 as well. And so you end up with 2 and 3 and 3, which gets you the same exact answer. Try example 2, 84. What can you divide 84 by? Or what two numbers multiply to get you 84? Well, I did 42 and 2 because I just decided, let me just divide it by 2. And then half of 84 is 42. So I can break down 42. What numbers multiply get you 42? I think 21 and 2. And what two numbers or multiply to get you 21? Well, 7 and 3. So I can't break down 7 or 3, so those are all my prime factors. I have 7, 3, 2, 2, and let's put them in order from least to greatest. 2 times 2 times 3 times 7. I have a pair of 2's right here, so I can rewrite this as 2 to the second power times 3 times 7. Box that answer. Let's try another example. Example 3, we have 48. So what numbers multiply get you 48? I have 8 and 6, and I can break down both 8 and 6, but let's do 8 first. 2 and 4 get you 8, and let's break down 4. Sorry, let's take down 6 next. What two numbers get you 6? 2 and 3, and those can't be broken down, but 4 can be broken down, so that can be broken down into 2 and 2. And it looks like those are all prime, so circle, 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 circle. By the way, if you decide to circle them as soon as you find them as a prime, I think that's a good idea. Anyhow, let's order these from least to greatest. 2, 2, 2, 2, and 3. So I have 4 2's and a 3, so I'm going to rewrite that as 2 to the 4th times 3, because there are 4 2's. Let's go, box our answer. Let's try example 4. So 64, what two numbers multiply to get you 64? 8 and 8. Let's break down 8. 2 times 4. Now, you may want to just circle the 2 right now if you want to. That's a good idea. Anyhow, I'm going to keep going. 8 is 2 and 4. And 4 can be broken down into 2 and 2. And this can also be broken down into 2 and 2. So we have 2 and 2 and 2 and 2 and 2 and 2. That's 1, 2, 3, 4, 5, 6 2's. All the same. So we can rewrite this as just 2 to the 6th power. All right, we are going to try a different method. We're going to use the ladder diagram to find the prime factorization of each number now. Now, I don't like the ladder method as much. It looks a lot like the ladder method for GCF, or finding GCF or LCM, except you're only finding it for one number. Now, what prime number can you divide from 20? Well, 2. And 2 times what equals 20? Well, 2 times 10. Now, can you divide 10? You can. Divide it by 2, and you end up with 5. And can you divide 5 by anything? Nope, you cannot, except for 5. So 5 is prime, so we stop our ladder there. So what this is 2 times 2 times 5. Now, how did I get that? Well, all the outside numbers, all the numbers outside of the ladder. So 2 times 2 times 5, which is 2 to the second power times 5. Pretty nifty. Now, something you need to be, I guess we'll talk about it later. But 56, let's try that again. I'm going to take out a 2, which leaves me with 28. And I could divide that by 2, which leaves me with 14. I can divide this by 2, which leaves me with 7. And 7 is prime, so I'm going to stop there. So now I have 2 times 2 times 2 times 7. And that can be simplified to 2 to the 3rd power times 7. So, kind of nice, kind of clean, but I don't always like it, and you'll see why shortly. We have 40. We're going to pull out a 2, and that gets us 20, and we pull out a 2, and that pulls out 10, and we're going to pull out 2 again, and that leaves us with 5, and 5 is prime, so we stop there. 2 times 2 times 2 times 5, well, that is 2 to the third times 5. And it seems all great, but some of you were looking at that 40, and you may have been thinking, you know what, why don't I just pull a 10 out of it? Or pull out a 5, or pull out a 4 even, and leave us with 10. And then just kind of go, oh, well, I pull out a 5, and that leaves us with 2. So that leaves us with 2 times 4 times 5. This is not correct. Now, why isn't it correct? Because 4 is not a prime number. 4 can be broken down into 2 and 2. So using this method, you have to only factor out prime numbers. You cannot factor out other numbers. So you can use you can use 2 and 3 and 5 and 7, but you can't use numbers like 4 and 6 and 9 because those are not considered prime. Anyway, let's try one more. Number 8. So 540, what numbers can you divide it by? Because I'm tempted to pull out a 10, but let's go ahead and divide it by 2, and that leaves us with 270. Divide that by 2, and that leaves us with 135. Let's divide that by 5 because it ends with a 5, and I'm left with 27. You can divide that by 3, and that leaves you with 9. And you divide that by 3, and that leaves you with 3. And 3 is a prime number, so we're going to stop there. So we have 2 times 2 times 5 times 3 times 3 times 3. Order it from least to greatest. So we have 2 2s, 3 3s, and a 5. So 2 times 2 times 3 times 3 times 3 times 5. Simplify it. Since we have 2 2s, 3 3s, and 5s, we go 2 to the second power, 3 to the third power, times 5. And that's it. Now we know how to factor it using the ladder diagram and the factor tree method. Go ahead and try some on your own. Good luck.